Namaste. This is Navanoda M. Patil, studying in Sri Venkateswara College of Engineering. Today's topic is power generation. First, introduction to power generation. Power generation is a process of converting various forms of energy into electrical energy. It is a critical component of modern society, powering homes, industries, and infrastructures. Understanding power generation method is essential for addressing energy demands and sustainability challenges. View of energy sources. Energy sources of power generation can be classified into renewable and non-renewable categories. Non-renewable sources include fossil fuels like coal, oil, and natural gas, which are finite resources. Renewable sources encompass solar, wind, hydro, geothermal, and biomass, which are sustainable. Hydropower generation. Hydroelectric power generation uses flow of water to turn turbines and produce electricity. It is the largest source of renewable energy globally and provides significant baseload powers. Environmental impacts such as ecosystem disruption are important consideration in its development. Next, solar power generation. Solar power harnesses energy from the sun using photovoltaic cells or solar terminal systems. It is an increasingly popular renewable energy source due to its scalability and decreased cost. Solar energy system can be developed at both small and large scales from rooftop to solar farms. Conclusion. Power generation is undergoing a significant transformation driven by technologies, advancement, and environmental concern. The transition to renewable energy is essential for sustainable development and combating climate change. Continued innovation and investment and public engagement will shape the future of power generation. Thank you. Next, wind power generation. Wind power generation electricity by converting the kinetic energy of wind to turbines. It is one of the fast growing energy source globally, driven by technological advancement and policies. Wind farms can be located onshore or offshore, with offshore wind being particularly potent due to stronger winds. Next, nuclear power generation. Nuclear power generation utilizes nuclear fission of produce heat which is then converted to electricity. Nuclear power plant have a high capacity factor, meaning they can produce a large amount of power consistency. Concerns regarding safety, radioactive waste, and public prescription continues to challenge its expansion. Next, geothermal power generation. Geothermal power traps into the Earth's internal heat to generate electricity. It is a renewable and efficient energy source, particularly in the region with volcanic activity. Geothermal systems have a low environmental footprint but are geographically limited. Next, fossil fuel power generation. Fossil fuel power plants burn coal or oil or natural gas to produce electricity. These plants are prevalent due to their stability, technology, and infrastructure. However, they contribute significantly to greenhouse gas emission and climate change. Next, biomass power generation. Biomass power generation convert organic material into electricity through combustion or biochemical processes. This form of energy is considered renewable, provided that biomass is stored sustainably. Biomass can help reduce waste and leverages existing agriculture practices for energy production. Next, energy storage technologies. Energy storage is crucial for balancing supply and demand in power generation. Technologies such as battery pumped, pumped hydro storage and flywheels help store excess energy for later uses. Effective energy storage system enhance the reliability and efficiency of renewable energy sources. Next, environmental impacts of power generation. Different power generation methods have varying environmental impacts from emission to habitat description. Transitional to cleaning energy sources in critical for reducing the carbon footprints of electricity generation. Policymakers must balance energy needs with environmental protection to promote the sustainability practices. Future trends in power generation. The future of power generation is shifting towards the greater reliance on renewable resources and advanced technology. Innovation in energy efficiency, carbon capture, and distribution generation are on the rise. Policy frameworks and public support are essential to accelerate and transition to a sustained energy function. Conclusion. Power generation is undergoing a significant transformation driven by technologies, advancement, and environmental concern. The transition to renewable energy is essential for sustainable development and combating climate change. Continued innovation and investment and public engagement will shape the future of power generation. Thank you.